Hey, welcome back. I'm going to talk about this interview problem number 3 today, and I've divided it into two parts. So in part 1, I'll solve one problem, one version of the problem. In part 2, I'll solve another different version of the problem. Before I get into the problem, just wanted to thank all of the subscribers. I'm delighted to see that many of the subscribers have joined, and that actually gives me a lot of encouragement to carry forward and bring it to you different kind of solutions to different kind of problems. Now, coming back to this particular problem, so this is a probability problem that I'm going to solve today. So let's look at the problem first. So John samples from the uniform 0 to 2 distribution, and then Jenny repeatedly samples from the same distribution until she obtains a number higher than John's. So question is, how many samples is she expected to make? This particular problem can appear in many of the competitive exams, and as well as these kind of questions are asked in the quantitative section in the interview questions as well. So if you want to try it out at this moment, you can pause the video and try to solve the problem. But otherwise, let me give a solution to this problem. So first, let us assume that John samples a number which is x, and Jenny samples a number which is y. Okay. So now what happens is the probability that Jenny's number is more than John's, then essentially we need to have this probability of y larger than to be larger than x, which is basically, since y is from the same distribution uniform 0 to 2, so probability that y is between 2 and x, right? And if you calculate this probability, that becomes the 2 minus x by 2, which is 1 minus x by 2. So basically, if John chooses the number x, then the probability that Jenny's number is larger than John's, that probability is 1 minus x by 2. Now, similarly, the probability that Jenny's number is less than or equal to that of John's, that is basically nothing but probability y less than equal to x, which is 1 minus the probability that we just calculated in the above step, that is 1 minus x by 2. So this expression is 1 minus x by 2, which is equal to x by 2. So the probability that Jenny's number is less than or equal to John's is basically x by 2. Now, let us assume that the random variable n, basically this is the important random variable here, denotes the number of repeated sample Jenny is needed to draw to get a number higher than that of John's. So basically, this is the random variable that we are working with, that is the random variable n, and we essentially want to calculate the expected value of n, because the question is, how many samples is she expected to make so that her number is larger than that of John's. So let's move forward and let's first observe that n can take the value 1, 2, 3, and it can go on. It can take the value infinitely large values as well, right? So how do we find any distribution of n? Let's first try to look at that. So now let us compute that probability that this capital N takes a value that is equal to small n, given that John sampled a number which is x. So probability that Jenny samples a numbers smaller than that of John's in the first n minus 1 draws, and in the nth draw, Jenny samples a number that is higher than that of John's. Then only this n can be equal to, capital N can be equal to small n. And we obviously condition this still on that, given that John sampled a number which is equal to x to start with, okay? So John has sampled a number which is equal to x to start with. So now if we look at this, then the probability that that Jenny chooses a number which is smaller than equal to x in the first n minus 1 trial, that is basically x by 2 whole to the power n minus 1, because we have already calculated that the probability that Jenny's number is smaller than equal to that of John's is basically x by 2, right? So n minus 1 trials, she chooses the smaller number, that is the probability is x by 2 whole to the power n minus 1. And then in the nth trial, she chooses a number which is larger than that of John's. That probability is 1 minus x by 2. So if you look carefully, this is actually called a geometric distribution with success probability being 1 minus x by 2. So we now know that capital N is actually following a geometric distribution, right? So now, based on that, if we move forward and calculate the expected value of N, given that John has still sampled the number X, that is basically expectation is nothing but the value that the random variable N takes multiplied by the probability with which it takes that value. So basically, in this case, the value taken by is small n, and the probability with which it takes that value is x by 2 whole to the power n minus 1 into 1 minus x by 2. And then actually we sum it over all possible values that this random variable capital N can take, which is equal to 1, 2, 3 up to infinity, right? So if we take this, if we try to do the sum can be done in many ways. So one of the ways basically just consider the geometric progression and take a differential, and basically you can do the sum, which basically resolves into 1 by 1 minus x by 2, which is also, if you are aware of geometric distribution, that for geometric P, where P is this probability of the success, the expectation is basically 1 by P, which is, in this case, P is equal to 1 minus x by 2. So that becomes 1 by 1 minus x by 2, which resolves into 2 by 2 minus x. So now we know that this is the expected value of N, given that John has sampled the number X. Now in the next trial, what we are going to do, we are going to actually calculate this expected value of N. And we will take out this condition that John has sampled the number X. The way to do it is basically still use the condition expectation of N given X, that John has chosen the number X, and then the probability with which he can choose the number X, which is basically half, and then integrate out this X value on the entire horizon, that the horizon of the values that X can take, which is basically 0 to 2, which essentially becomes this 2 by 2 minus x multiplied by half, which resolves into 1 by 2 minus x dx, integration from 0 to 2, which if we do is basically it's just a log of 2 minus x minus log of 2 minus x, and the range of the values is 0 to 2. And if we put the values, this particular number becomes infinity. So essentially this means that JEE has to actually sample infinitely many times to get a number higher than that of John's, right? It may come a little bit non-intuitive to start with, but the reason for that is, as you see, if John has chosen a very large value of x, so let's say x is very close to 2, then the probability with which JEE actually can choose a number which is larger than that of x is, this probability is very, very small, which makes this success that JEE actually gets a number which is more than that of John's. To get that number, she has to make number of expected number of draws she has to do is basically 2 by 2 minus x, which is essentially a very large number. And this large number actually makes this expectation go very, very high. And that's why we finally get an answer that JEE has to actually sample infinitely many times to get a number which is larger than that of John's. This kind of problem, the trick to solve this kind of problem is basically, first, these are easily can be solved with conditional distributions. That's what we have done. That we have started with the assumption that John has chosen a sample which is x, and then tried to solve the entire question. I hope you like the video. I hope this is helpful to you. If you like the video, if you like the channel, please do subscribe. Please share it with your friends. Please provide comments that what kind of problems you want me to solve. I hope to come back to you with the next video at some point of time. Thank you so much.